Hello, CHEM chemists. I'm here today to work through the Module 7 materials. So I'm Kim Koska, one of the instructors who designed this course, and I'm really happy to walk you through that today. So let's go ahead and take a look at our presentation on Module 7. Let's go ahead and start our slides. So Module 7 is focused on gas laws, and here's this just beautiful, hopefully inspiring image of what we might do with gases, right? We might fill balloons with them and go for a trip. So kind of exciting. But what we're going to be doing is taking a look at 3 different parts. Part 1, states of matter, Part 2 on gas laws, and Part 3 on gases in the workplace. The other thing that we're going to be doing is 2 different assignments. So when we're looking at the states of matter and gas laws, it's more about the physics that underlies that, the chemistry, and then mortuary workplace gases are for safety. So again, we've got an assignment on gas laws. It's a simulation, and we've got a quiz to work through too as well. So you'll learn more about those. They each have their own, or that have their own video. This is just a reminder that we do have extra resources in our materials for this module. So don't forget that we've got a pretty good textbook, and it's free, and all of the pages are there you can click on. And each of those readings has exercises attached, and an answer key is included with each of those exercises. So it's handy to work through those before you take a quiz, for instance. So let's go back and review a little bit about the states of matter. Maybe it's been a while since you've had middle school physical science, so let's take a look at these. So we primarily on the Earth consider solids, liquids, and gases. There is another phase called plasma, and that's really important if you were studying stars or high temperature electricity. But for us, we're looking at solids, liquids, and gases. So solids and liquids are what are called condensed phases of matter because the particles are close together, so they're condensed. So in those phases, the particles are near, and in a solid, they're locked into position and they don't move past each other. In a liquid, the particles are close to each other and they flow past each other. In a liquid, we occupy the volume of our container and can move with the shape of the container, but the liquid is constrained into a fixed volume. In a gas, however, the particles are far apart and they can assume the volume of any container that they're in, so whether the container is a vessel or a room. So there are some videos that you're going to have access to, and those videos will walk through the ideal gas law and other gas laws. So the gas laws are all named. You don't have to know their names, however. What a gas law is just a description of gas behavior. So don't let the word gas law intimidate you. It's really just a description of how different properties affect each other and how different gas variables affect each other. So nothing really unusual there. Okay, so one of the things that's going to come up in your assignment that you'll do, and you'll see it in the gas law videos and readings, is 4 different variables. The first of these is volume, and you're already familiar with that, right? It could be liters, milliliters, gallons. So we're going to look at volume as one way to describe a gas. We also describe gases by looking at temperature. One interesting thing about gases and temperature is that if we do calculations, we use an absolute temperature scale of 0 of Kelvin, and 0 Kelvin represents the state where all molecular motion comes to a stop. And we could easily adjust those. You won't be doing any calculations, so you won't have to worry about that temperature correction. We also have the variable of pressure. So with pressure, we might be looking at things like atmospheres as a unit, or we might be looking at things like pounds per square inch, or millimeters of mercury, or inches of mercury, torr. So these are all different kinds of pressure units that we might use. The metric unit of this is kilopascals. So we use whatever pressure unit is convenient for whatever it is that we're measuring, basically. If we're looking at weather, we'll probably use millimeters of mercury. If we're looking at the tire, we'll be looking at PSI. The other variable that we come up upon is called amount. And this amount, for a chemist, we use moles, which is a counting term, right? We can count the particles of a gas with this term mole. However, you're not going to be doing any calculations with gas laws, so you don't need to necessarily know how to calculate the moles of a gas. Instead, you're probably going to find it more useful to think about the mass of a gas. And those things are related. The higher the mass, the more moles we have. So you'll come across those variables as you're working through the simulations and as you're looking at the videos. So the other thing to know is that we're going to make a transition to looking at safety in the workplace. And in safety, we're going to primarily focus on formaldehyde. When we're working with formaldehyde, it is toxic, so we have to be super careful. And all of the materials written about safety generally talk about the concentration of formaldehyde. So we have a simulation that you can use to get yourself familiar with concentration units for gases. So we're going to start out in the simulation at 100 parts per 100, and then we'll go to parts per 1,000, and that sets you up to understand the common workplace units of parts per million and parts per billion. All right, so go ahead and play around in that simulation just to get familiar with how that works. The simulator doesn't go up to 1,000,000, it goes up to 1,000, so you'll be cut off at that point. There are some fact sheets in this module, and you definitely want to download and review the OSHA fact sheet about formaldehyde. And you may even want to print that one out because you'll probably want it handy for the quiz that you're going to do for Module 7. That fact sheet is again written by OSHA, which is a federal regulatory agency that monitors workplace safety. You'll find when you're working through those that there are some terms that come up, and these are going to be part of the quiz, so you'll want to read carefully about these. One of them is the PEL, or permissible exposure limit for formaldehyde. Another one is the STEL, or short-term exposure limit. And the other one that comes up in that paper is the weighted average, so the time weighted average, TWA, and those are generally based on 8 hours, which is sort of a typical standard workday, at least defined by OSHA. The other information that you'll run into is this kind of fun table that shows how humans perceive different smelly materials. And we have perception limits that, yeah, if it's not enough, we can't smell it. And if it's above that, we can smell it. So for instance, if we look at ammonia on this table, the third one down, there's a threshold to what we can detect. So that detection threshold is 17. And at 17 parts per million, we might say, I smell something, but you won't necessarily know what it is until you get up to 37 parts per million. So go ahead and take a look at this. You'll get a feeling for what our detection limits are and what our identification limits are for different kinds of odors. Even though we can detect things at the parts per billion range, for instance, methyl mercaptan, which is put in natural gas so that we can smell it if there's a leak, we're nowhere near what a dog can smell or other animals. Our sense of smell is quite poor relative to other mammals. And it's basically built on because of how our nasal cavities are built. There is also a video that you can view to help you walk through parts per million and parts per billion and percent. So all of those are related to each other, and that's helpful. We also have an explainer that you can download and review, and that shows some everyday concentrations, relating those to parts per million. And when I say everyday concentrations, I'm talking about every day for a scientist, right? Because we're working with grams and kilograms. Although there are a couple of relations in the explainer to quarts and gallons, for instance. So go ahead and work through that explainer, and it's another one that you might want to just have handy before you take your quiz. Highlight it, read it, review it, and come up with questions if you've got them, and we can pick them up during office hours. So move on to the next slide here. So then that wraps us up with our assignments. Like, there are 2 assignments again, and there's a video that walks through the gas law simulation assignment. So feel free to work through that video and prepare yourself for that. And the simulation's kind of fun. And then we've got, in the end, a quiz, and the quiz has a ready reference with the OSHA fact sheet and the explainer. So you'll want to have those handy for you when you go to that quiz, which again is focused mostly on workplace safety. So good luck with Module 7, and I really, really hope that you'll come and visit us during office hours. And if office hours don't work for you, we're happy to schedule a time to get together with you, and also really happy to answer questions that you might post in discussions. So good luck with Module 7.